Welcome. In this series of videos, we'll talk about the Hacker Robot program and go through kind of step by step how to take an old RC car that you can get from a thrift store for a few dollars like this one and turn it into a kind of robotics platform that we can use to continue adding sensors and inputs to. This one right now, of course, is kind of in a prototyping stage, but is able to drive around autonomously according to the programming that we put into it. It even has a bit of a throttle control so we can adjust the speed of the motors. But from here we could build out ultrasonic sensors on it, put some limit switches so if it runs into a wall it knows what to do, all kinds of stuff. It's a great project because RC cars like this, I usually don't pay more than I did for this one, which is $4.99, which would be basically just enough to cover the cost of motors. And here you get wires already attached and a beautiful gearbox and steering mechanism. It's a great way to go. So first step is kind of looking through your car selection, what you're going to use. This one here is a good example of the things I would look for before investing. First of all, you want to make sure that it is able to steer. So make sure those front wheels aren't just fixed in place. There's a lot of thrift store toys out there that just blink and maybe move forward and backwards but can't steer. Check that the steering still has some springiness to it. That's going to be really helpful if it returns to center when the motor isn't powered. And that nothing's broken on it. So there's a lot of little pieces here that can sometimes be abused, including this tracking piece that can fall out sometimes. On the back, it's always worthwhile to spin both the motors. Make sure you can feel a little resistance and hear that there's some gears back there. This one seems to check out. And then it's always kind of good to look at what the power supply for these are. The simplest to work with would be if it's just like AA batteries, which this one is, I believe. We'll open this up in a second and see. A lot of newer RC cars are having rechargeable battery packs included in them, which might be a little bit more difficult to tap into. Of course, we can always add our own kind of battery holders to power the motors, so it's not a huge concern. Okay, so first things first, we're going to want to open this up and get rid of all the cosmetic stuff that we don't need, and it's different on every car. I can already see with this one, there's a bit of springiness on the back here, and that spring looks like it's connected to part of the upper casing. So I may need to disassemble this to find the wires and cut out the circuit board, and then reassemble it at least a little bit, so this has that spring still involved. The first thing to do is enjoy the hunt here as you try to find all the different screws and take them out. So I'm going to try to take out all the ones that I can see on the casing, but I want to be careful I don't go too deep and open up the gearbox. If that springs apart, usually there's going to be greasy gears that will fall out, and it's really hard to reassemble it. And same thing with the steering. I don't want to remove any critical screws here that are holding this part together, so trying to avoid those. If we encounter any wires, we can also cut those out, like this antenna. We don't have the controller for this anymore, so this literally does nothing. We're going to cut out the whole circuit board anyways. Okay, right here, I'm going to pause for a second because I wasn't sure where it was, but there's always going to be kind of the brains of the car in here somewhere. The circuit board that has the receiver built onto it that the controller would have communicated with. Our goal here is to find all the wires that attach to the circuit board and cut them as close to the board as possible. Those are going to be the wires that are typically coming from the driving motor and the steering motor and the power supply, and then the antenna, of course, which we're not going to use. So let me get this circuit board popped off and then we'll find those wires and cut them close. All right, so now we can see the bottom where all those wires attach, and I'm just going to use some diagonal cutters like these, which are great for snipping wires close to a surface, and get these all freed. And then just toss my circuit board away. We don't need it. We're going to be replacing the brains with our own microcontroller like an Arduino Uno. I'm going to try to continue here a little bit more and see if I can get any other plastic parts off just to give me a more level work platform. Okay, so at this point in this car, if I take off the gray plastic piece on the top here, it looks like the spring on the back is not going to be able to attach to anything. So I'm going to leave it on. I may choose to come back in later with some actual tools and perhaps cut off the parts that are not required, just so we got some more space. But this is pretty narrow for mounting our other components like our relay module and Arduino. So I'm thinking I might just have to attach some cardboard or pieces of wood here. So I've got a larger platform to work on. Good. So that's a great start. Next step is going to be to perhaps test our car before we get any more involved here. Try to figure out which wires are controlling which motors and making sure that they still have some life in them. So I need to strip my wires so that I can make a connection there. I've got some wire strippers here, and it's got all the different sizes for the gauges there. This pair is pretty small. I usually try to choose one that I think is going to be too big and then work my way down until I find one that is pretty nice there. So for me, it looks like about the third one down from the end is going to work out. Cut through that insulation and then slide it off. And I'm only taking off about a centimeter. Don't need to expose a whole lot. So I've grabbed a 9-volt battery, probably a little bit higher than the voltage a car like this would take, probably closer to 6 volts. But I'm going to use this just to connect to the terminals and try to figure out which pairs of wires here go to what. So I can actually peek in and actually see that the green and the brown are connected to the DC motor for the steering. So let's just check that it's actually alive still by tapping these and seeing if we can get it to turn that motor for us. It helps if I use a live battery. All right, I've grabbed a live new 9-volt battery here, and I'm going to tap it on these pairs of wires to see if I can figure out what controls what. I can see in that the green and the brown look like they're attached to the wires or the motor that steers. And if I complete that circuit, it looks like one way it's going to turn to the left, switch the terminals around, and that makes it turn to the right. So green and brown are a pair that go together. I'm just going to loosely hold those together so I remember that. Red and black, blue and white, colors don't usually mean anything for sure, but by convention, often red and black are associated with power. So I'm going to guess that blue and white here are for the back motor, and I'll do the same test with my battery. Okay, so that made it move backwards, and if I switch the direction of the current, that makes it move forwards. Excellent. So the motors work. That's a great sign and something that we want to find out early before we go too much further. I'll put in some new batteries between now and the next video, and we'll be able to check to see if the terminals in the battery are good. Sometimes old cars, you'll need a little cleanup in there, just scraping the contacts to make sure that it's actually good.